underneath number 1, because that's the only one we did. Draw a squiggly line. And then write today's date, January 26th, 2021. And then we're starting with number 2. Okay, so yesterday we talked about climate. What is climate? Aaron.
The pattern of seasonal weather that happens year after year.
The pattern of seasonal weather that happens year after year. So what is it typically like in a certain place at a certain time of year? What is the weather typically like in a certain place at a certain time of year? Then we learned about the climate regions. What are the climate regions? There's 3 climate regions. There's 3 main climate regions. There's more than that, but there's 3 main climate regions. Mason, tell me one.
Cold
Nope. There's specific names for them. Let's see, Smith, tell me one.
Polar.
Polar regions. What are polar regions like, Smith?
Very cold and dry.
They're cold and dry. What's another one, Aaron?
tropical.
Tropical regions. What are tropical regions like?
Very rainy and warm.
Warm and wet. And what's the third one? Cullen?
Temperate.
Temperate. And what are temperate like? How can you say that? Is there a specific thing? Is there a specific description? Are temperate regions cold and dry? Zari, are temperate regions cold and dry?
No.
Are they hot and wet?
No.
So what are they?
It's like one side is pretty cool and like dry and
Smith, can you help her out?
it's in between tropical and polar.
It's everything in between. It's not cold and it's not cold and dry. It's not hot and wet, but it's everything in between. Cold and wet, hot and dry, warm and wet, warm and dry, cool and wet, cool and dry, very mild and mixed everything. Polar regions are cold and dry. Tropical regions are hot and wet. Temperate regions are all the different regions in between. So are temperate regions only one way? Are they only hot and dry? Or cold and wet? Or mild? Or a mixture of everything? No, they're all different things. We just describe everything in between as temperate regions. Now there's lots more because they get into details, but we don't have to know that as 4th graders. Okay. Then we started talking about what determines climate. So what makes climates what they are? What was the one thing that we did talk about yesterday? Cullen.
Latitude.
Latitude. How does latitude help to determine the climate? Latitude tells us what? Zari?
Latitude tells you how far or close you are to the equator.
Okay. So if the latitude tells you you're closer to the equator, what is the climate more like? Cullen?
Hot and rainy.
Hot and wet. If you're further from the equator, what's the climate like? Carla?
Cold and dry.
Cold and dry. Because if you're further from the equator, you're closer to what? Zadie? The poles. What's the climate region of the poles? The North and South Pole. What's the climate region called? What type of climate region does it have? Anybody can answer this question, not just the people that have been answering all the others. The poles are part of what climate region? Colin?
The polar region.
Polar climate regions. That's where the word polar comes from. The poles. The base word of polar is poles. The poles are cold and dry. That means polar regions are cold and dry. If you're close to the equator, what is the climate region that you are in? Carla?
The climate region is going to be tropical.
It's gonna be tropical. If you're in between, like you're halfway between the equator and the North Pole, what is that climate region that you are in? Come on, guys, I have like the same 5 people raising their hand every time. Everybody is able to answer this. Zari?
Temperate.
Temperate, in the middle, a mixture. Ooh, this doesn't look good. I feel like I have 1, 2, 3, 4, 5 people in this classroom right now. That includes girls at home. There's only 3 people missing. I'm sorry, 2 people missing. So that means I should have 9 people in this class right now, not just 5. Okay. Read next. Ethan. We finished latitude, so where are we now? You're not on the right page. Carla.
Global wind.
So here's another thing that affects climate. We know latitude. Well, that would mean everything near the equator is hot and wet, and everything near the poles is warm and cold. But then why are things in between different? Well, here's one of them. Go ahead and tell us about it, Carla.
Global wind. Temperatures different between latitudes can cause global wind. These are winds that move air between the equator and poles. Warm air near the equator rise and move towards the poles. Cold air near the poles sink and move towards the equator.
Good. So if latitude was the only thing that told us, that determined climate, that would mean it would never rain or snow up in the poles because it's supposed to be dry. And that means it would never be dry around the equator because the equator is supposed to be wet. But is that the case? No, it would mean we would have temperate, which means we would have in the middle all the time. Is our weather in the middle all the time? Not really cold, not really hot, not really warm, not really dry? No. So global winds are one of those things because think, wind is moving air, right? If the air is blowing through, it's moving through the equator and coming north, what is the temperature of that wind going to be? It's blowing from the equator up to like into Canada. What's going to happen in the path of that wind? What's the temperature going to be like? The wind is starting at the equator and it's blowing up towards Canada. What kind of temperature is Canada headed for? Come on, guys. Wake up. The wind is coming from the equator. It's blowing up into Canada. That means, even though it's in Canada, which we think of as cold, it's in the path of that global wind coming from the equator, so what temperature is it going to be? Mason?
Hot.
Warm or hot? It's going to be warm because why? Mason?
Because the equator winds are blowing into Canada.
Okay, and why would winds coming from the equator be warm?
Because the equator is really hot.
Because the equator is hot. So if air is coming from the equator, that means it's going to be warm. What if air from the South Pole is blowing up into southern Africa? What does that mean about all the places in the path of that air from the poles blowing into Africa? Aaron?
It's going to be cool
It's going to be cool air.
air.
Why?
Because the poles are cold.
The poles are cold. So if you're getting wind from the poles, that means what kind of weather are you headed for? You can tell me the temperature. If the wind is coming from the poles, what kind of weather are you in for? Victoria?
You're in, like, your weather's gonna be, like, probably maybe
Your two, are the poles wet? Do they have a lot of precipitation? So if the wind is coming from the poles, does that mean we're going to get snow? Because snow is what? What is snow an example of?
Snow is an example of
Precipitation. Now, yes, we know the poles have a lot of snow, but that's mostly because, sorry, hand down, please. You're not listening to what I'm saying. You're thinking about your question or what you want to say. The poles have a lot of snow because they do get some precipitation, and normally, if we get snow, it'll melt. But at the poles, does it ever get warm enough to melt all that snow? No. So it just builds and builds and builds. Even though it rarely ever actually snows, that snow is from like months ago and it's still there, maybe even years ago. Or maybe even ice ages ago. So, if the air is coming from the poles, whether it's coming south from the North Pole or north from the South Pole, what kind of weather are you headed for? Zadie?
cold weather.
Cooler weather. If the air is coming from the equator, what kind of weather are you headed for? If you're getting global winds from the equator, what kind of weather are you headed for? Aaron? Warmer weather. So global winds make a difference. Otherwise, everything between the equator and the North Pole or the South Pole would never change. But global winds also add to that. So even though it's cold right now, what might we have gotten yesterday? What might, now this isn't necessarily definitely what happened, but what might have happened yesterday? Mason?
It might have been hot.
Well, okay, but why? Think about what the temperature was like yesterday. You all went outside at least once. Well, I don't know about girls at home, but everybody here I know went outside at least once because they came into school and they left school. What was the temperature like yesterday? Aaron? It was warm, but it's January, so what might have happened to cause it to be warm? We didn't get any closer to the equator, did we? No. So what might have happened to make it so warm yesterday in January? We might have gotten air coming up from the equator. We might have gotten some of these global winds coming from the equator. Now, some days, remember like 2 years ago, the beginning of June was like really cool and nice, and you kind of had to wear jackets? Why do you think that might have happened? That's not normal for Memphis in June. Cullen, did we move closer to the North Pole?
No.
No. So what might have happened?
The wind probably came from the North Pole.
We might have had some wind coming from the North Pole. Wind can come from really, really far away. Especially because sometimes it's wind, we don't necessarily feel it, but it's the air still moving, right? So, a big gust of wind is not what this is. Like yesterday when it got real windy. That was from the storm. But global winds are ones that we don't really feel as much, but they're there. It's the air moving. That's what can cause the fronts. Remember you read about the fronts in the last lesson. Okay, well, latitude and global winds are not the only things that can cause changes in climate. What else causes our climate to be what it is? Aaron. Loud and slow.
Ocean current. A current is a directed flow of gas or liquid.
What's our next word?
Current.
Current. And what is a current, Aaron?
A directed flow of gas or liquid.
A directed flow of gas or liquid. Now, directed flow means it's moving in a certain direction. It's not like a puddle that just goes all over the place. It's moving in a certain direction. So think about a current on a river. If you get caught in a current on a river, are you just going all over the place? No, you're moving along with the current. If you're canoeing or something, you want to find the current because it makes it a lot easier for you because you don't have to do as much work. The current does a lot of the work. You just help it along to maybe move a little faster. Okay, Aaron, keep going. Bless you.
Some ocean currents move warm water from the equator to the poles. Others move cold water from the poles toward the equator. There are also currents that move along lines of latitude. Together, these currents form circular patterns in the ocean.
So remember, well, actually we haven't learned this yet. I'm remembering this from last year. Well, no, I think we learned this in social studies. Depending on where you are, if you are near an ocean, that ocean will definitely cause the temperature to be a certain way. If the water is warmer, what's going to happen to the temperature of the air around it? If you live near the ocean or a massive body of water like the Gulf of Mexico or the sea, what's going to happen to the air temperature if the water is warmer? Zari.
It's going to get warmer.
It's going to get warmer. What would happen to the air temperature if the water is cooler? Come on, guys. This doesn't even really take much thought. Victoria.
It's going to get cooler.
The air temperature is going to get cooler. So, ocean currents work the same way as those winds, but instead of moving air, it's moving what? Ocean currents work very similarly to the global winds, but instead of moving air like the global winds, ocean currents moves what? Smith.
Ocean currents move water.
They move water. Come on, guys. Some of you are just completely ignoring. It's going to be real hard for you to do this homework tonight. Very hard. Obviously, everybody who didn't raise their hand right now needs to really think about where their brain is because it's not here. Because it's very obvious that if global winds move air, ocean currents move water. Because the ocean is made of what? Class? Water. So, let's look at this diagram at the top of page 348. I am not going to ask you again to put your legs down and scoot your chair in because you are not listening. Put your hands on your desk. Look at the diagram on the top of page 348. We see all those arrows. What do the red arrows represent? Mason. A warm current. Everybody find the equator. How do you know which one is the equator? How do you know which of those lines of latitude across is the equator? Zari.
Because it's 0% Fahrenheit.
0 degrees. Yes, 0 degrees, not Fahrenheit, but just 0 degrees. So everybody find the line that shows 0 degrees. Now follow it across. That is the equator. Look at those red arrows. Where are all of the bottoms, not the pointy end of the arrows, but the bottoms of the arrows coming from? Look at the red arrows and look at where the bottom of almost every one, except for one, are coming from. Victoria.
They're coming from
Zari?
The water.
Okay, all of the bottoms of the arrows are in water. Every single one of those bottoms of the arrows are in water. The bottom of the arrows, the red arrows only, are coming from where? Cullen.
the North Pole.
Aaron. The equator. Look at all the red arrows. There's one random one that is not doing this. The red arrows are all pointing away from the equator, which means they are coming from what? Carla.
The equator.
The equator. Water coming from the equator would be what temperature? Zadie.
It'd be warmer.
It'd be warm. Why?
Because the equator the climate is warm and wet.
Because the climate is warm and wet. Ooh, I have some people that are really gonna struggle tonight, and I don't know what to tell them. I don't know what to tell them. Look at all those red arrows, except for that one along the coast of Africa. They're all coming from the equator. The ones below the equator are pointing down. The ones above the equator are pointing up. All of those red arrows coming from the equator are showing warm currents, because that warm water is coming from the warm area of the equator. Now, what do the blue arrows represent? Carla.
Yeah, the blue arrow. Actually, they said it was. Hold on, Miss Molly.
Okay. Carla, I'll call on you later, okay? What do the blue arrows represent? Aaron. The cold currents. Where are all the cold currents coming from? Look at it. Where are all the cold currents coming from? Find the bottoms of the arrows, not the pointy ends, but the bottom of the arrows. Where are they coming from? Smith.
They're coming from the poles.
They're coming from the poles. Good. I'm glad that you did not say North Pole or South Pole, because are they only coming from one of the poles, Smith?
No.
No, they're coming from both. And Zadie, that hand motion that you did shows me that you also saw they're not just coming from one area, they're coming from two. They're coming from the North Pole and the South Pole. Look at all of the blue arrows above the equator. So find the equator and look at all the blue arrows above. Where are those blue arrows coming from? The blue arrows above the equator. Where specifically? Cullen?
The North Pole.
The North Pole. But then all the blue arrows below the equator are pointing from a different direction, because they are coming from, Victoria? The South Pole. Water coming from the poles is going to be what? Carla?
Cold.
Cold. Why is water coming from the poles going to be cold? Carla?
Because maybe
No, maybe. We know 100% why they're going to be cold. Why would water coming from the poles be cold?
Because it's maybe near where the poles is, and it takes a long time to travel until it's near the equator.
Okay. Well, what do we know about the poles, Cullen?
The poles are cold.
The poles are cold. So water coming from the poles is going to be what, Cullen?
Cold.
Cold. Now, yes, Carla, by the time it makes it towards the equator, it's definitely not going to be cold anymore, but it'll still be cooler than water coming from the poles. And then we see all these black lines that represent what? Victoria?
The black lines represent
Other currents. Now, do they have a specific temperature? Do we know? No. Why do they not have a specific temperature? Smith? Why do you think?
Because they're coming from all over the ocean, not just the poles and not just the equator.
Good, because they're coming from all over. So it just depends on what temperature the water was where it started, right? Which, if that water was
Yes.
moving from the equator, it'll be a little warmer. If the water was moving from a pole, if that current starts there, it'll be a little cooler. Okay. Now there's one more thing that we're going to talk about that helps to determine climate. Zari, what is it?
Distance from water. Do you like to swim at the beach in the summer? You may have noticed that the water stays cool even on the hottest days. That is because the water heats up more slowly than land does. Water cools more slowly too.
So we know That's why we like to swim in swimming pools in the summer. Because think about if you're walking barefoot around the swimming pool. It's really hot, but when you jump into the water, does it feel like the deck around the pool? No, it feels cool, unless it's like August, then it kind of feels like a bathtub, but does it still burn you like the concrete around the pool does? No. That's why, because water heats up and cools more slowly than land. That's also why sometimes in like October, when it's getting cool outside, sometimes you may feel the swimming pool water and it doesn't feel as cold as the air around. That's why, because it also cools more slowly. Okay, read next, Victoria.
Remember that more than 70% of Earth's surface is covered by water. Land and water heat and cool at different rates. These differences affect the air temperature and precipitation nearby.
So, water being cool, land being hot, or the opposite, can affect the temperatures and the precipitation. Carla, go ahead and read next.
Remember.
Nope, we already read that. Carla, we already read that. So I have to call on somebody else. Oh,
Okay.
Michaela's not here. Me. Climates near lakes and oceans are cloudier and rainier than regions farther inland. Why do you think that climates near large lakes and oceans are cloudier and rainier than regions that aren't near large bodies of water? Aaron?
Because when it gets warm, the water evaporates and precipitates.
Because, well, what are clouds and rain made out of, Aaron? Water. Does it just appear out of nowhere? No. It's like you said, it evaporates from other bodies of water. So if there aren't any big bodies of water nearby, is there as much of it for to evaporate and turn into clouds and then rain back down? No. But if you're right near a large body of water, you might have a lot of evaporation happening. That water in the clouds builds up and then rains down. So if there's a lot of water, that cycle is going to happen a lot more quickly and a lot more often. Let's keep reading. Summers are cooler, winters are warmer. Nearness to water reduces temperature extremes. That means if you're near water, it's not going to get as hot in the summer. Now, this has to be large bodies of water. This doesn't count like a swimming pool in your backyard or even the Mississippi River nearby. This is large bodies of water, like oceans or really, really big lakes. If it's hot, it's not as hot in the summer as other places, and it's not as cold in the winter as other places. Think about the beach. If you go to the beach in Florida, Florida's further south, which means it's closer to what? Mason? The equator. But if you're on the beach in the summer, does it feel as hot there as it does back here in Memphis? No, that's because they're closer to what? Colin?
The equator.
Not the equator. The equator would make it hotter. But if you're at the beach, it doesn't feel as hot as it does back here. Now, it still feels hot, but not as hot as here in Memphis. Why is that? Mason?
Because you're closer to the poles.
Not because you're closer to the poles. We're closer to the poles than Florida. Florida is closer to the equator than we are. Please listen to what I just said. Being near very large bodies of water means that in the summer it doesn't get as hot as other places. It still gets warm, but not as hot. In the winter, it doesn't get as cold as other places. Memphis is further than the equator and closer to the poles than the beach in Florida. But for some reason, when we go to the beach on vacation, it doesn't feel as bad, even though we're closer to the equator and farther from the poles. Why is that? Why does it not feel as hot when we go to the beach in Florida, even though, because of where we are, it should feel hotter? Zari.
Because we're close to a big body of water.
Because we're close to a big body of water, which is exactly what this little section just told us. If you were listening, if you were not, if you were zoning out like many of you were, then you have no idea what I was looking for, and you said things that we learned about like yesterday. Okay, go ahead and turn the page. That's also why, even in places like Maine, do we think of the beach as being snowy? Even if we're like in places that are really, really cold, does the beach ever really get snowy? Because it stays a little warmer in the winter. Cullen, please read next. Now this page you need to really pay attention to and study. Because I'm pretty sure there's a question, a short answer question, that means critical thinking, about it on a test. So those of you that are zoning out, you better come right back in, otherwise you're really going to struggle. Okay, Cullen, please read.
How do mountains affect climate? Latitude, water, and winds are not the only factors that affect climate. Mountains also have an effect.
Keep going.
Altitude.
Not altid. Chunk it.
Altitude.
Now take out the pauses.
Altitude.
So what is that word?
Altitude. Altitude. Climates at the base of a mountain is always warmer than its peak. The higher the altitude, the lower the air temperature. Altitude is a measure of the height of a place above sea level.
Okay. Think about it. What do we sometimes see at the top of the mountains, even in summer? What do we sometimes see at the top of mountains, even in summer? Aaron? Snow. Does that mean where that whole mountain is, it's cold enough to snow? No, because does it go all the way to the bottom of the mountain? It's just at the top. That's because of this. The higher you go up the mountain, the higher the altitude, the lower the temperature. So even if it's like 100 degrees down at the bottom of the mountain, if the mountain is high enough, it could be like 28 degrees. And if there's any precipitation, it's going to be frozen and it's going to be snow. Read next. Smith.
What happens when an air mass meets a mountain? The air rises up the side of the mountain. As the altitude gets higher, temperature gets cooler. Water vapor in the air condenses into clouds.
So, sometimes we see clouds near the top of a mountain because, remember, the air hits the side of the mountain. We can look at this diagram up at the top with the arrows. We see the air hitting the side of the mountain, and does the air go right through the mountain? Can air go right through the mountain? Like it hits the side of the mountain and it just goes right through. Does it stop? What happens to that air as it's moving? Sorry.
It doesn't just stop where it goes or go through. It goes up.
It goes up and over. Well, the higher it goes, what happens to the temperature? Zadie?
The temperature drops.
The temperature drops. It gets cooler. So any water vapor that was in that air mass, what happens when it gets cooler? It was water vapor. It was a gas. What happens to it, Cullen?
It fell down.
No, it doesn't fall down. Smith?
It condenses.
It condenses, which means what happens to the water vapor? It started as a gas, it goes up, it gets cooler, and it condenses into
Liquid.
liquid, which means it becomes little tiny droplets that join together to create a what? Little tiny droplets. Come on. Don't act like that. Aaron? A cloud. A cloud. It's all right there in that paragraph. Plus prior knowledge. It says, as the altitude gets higher, temperature gets cooler. Water vapor in the air condenses. We know that from prior knowledge because that was a vocab word, so we need to know what condenses means. If you don't, you might be in trouble tomorrow. Into clouds. So that was nothing brand new that I was expecting you to make an inference about. It was all right there, or we already learned about it. So if you are struggling, that tells me you're not studying at all, and you are going to be in trouble tomorrow when you take this test. It is not going to be good. Okay, so now we know why sometimes clouds form at the top of the mountains. Mason, read next.
Clouds and precipitation.
A little louder.
As a cloud moves up a mountain, its water droplets get heavy. Precipitation falls. By the time air mass passes over the mountain, the air is dry. For this reason, the climate on one side of a mountain tends to be wet. The climate on the other side is often dry.
So that's what we're seeing. We talked a little bit about this diagram above, but now we know the whole story. Like Zari told us, the air doesn't stop when it gets to the mountain. That air mass that's moving across the land, it doesn't stop when it gets to the mountain. It doesn't go through it. It goes up and over. Then I think it was Smith told us that as it goes up, the temperature gets cooler and the water vapor condenses into clouds. What happens when we get enough of the water in the clouds? Colin?
It's snow.
Not necessarily snow. That happened. This happens in the middle of July in Memphis. Victoria?
It rains.
It not necessarily rains. Precipitation happens, whether it's snow or rain or hail or sleet. Whatever it is, precipitation happens. It goes up, it gets heavier and heavier. More and more of that water vapor is condensing into tiny droplets of water. Once it gets too heavy, precipitation starts. By the time it gets to the top of a mountain, it's kind of precipitated itself out. There's not much left. So then what happens to the weather on the other side of the mountain? Mason,
It dries out.
it's dry. That cloud has already rained itself out getting to the top of the mountain, and then it's on the other side of the mountain and there's not really any precipitation left. So we see that happening in this picture. We see where it starts with the blue arrow. It's going up the mountain. It's getting cooler, 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 cooler. It's raining, and then it gets to the top of the mountain and it kind of just goes away. Part of that is also because as it goes back down the mountain, what do you think happens to the temperature? It went up the mountain, got cooler, the water vapor condensed into tiny droplets of water, then it makes it over the other side of the mountain. And what happens to those tiny droplets of water? Or what happens to the temperature as it goes down the mountain? Zadie?
It gets warm.
It gets warmer, which means what happens to those tiny little droplets of water? What happens to those tiny little droplets of water as it gets warmer? Zari?
They melt.
They don't melt. That's what happens to ice. Water can't melt. Water's already melted ice. Only solids can melt. Water is a liquid. What happens, Zari?
It condenses.
Nope, that's when it turns into water from gas. It's already water. What happens to those tiny droplets of water? As they get warmer, we know this happens all the time, or we do if you were studying, which I can tell most of you were not. Maybe none of you. Zadie?
They vaporize.
Is that what we call it? Ooh, you guys have some studying to do. I'm not going to tell you the answer. You guys have some studying to do. Okay. Go ahead and close your books. You do have homework. You do have a test tomorrow. Whew. You can tell, even though I said bring your books home and study, I think that just went on a field trip in your backpack. I have a feeling most of your science books didn't even leave your backpack.